So one thing we're going to be using throughout the course in almost all of our labs is going to be unit testing. So what is unit testing? So why do we need to do unit testing? So here's a quick thought experiment. You're working in a group, right? You're working in a team to develop some piece of software, and then you and your teammates are all working on different parts of this code that we're going to put together, and the whole thing is going to come together to give us the right result, right? So maybe my function, right? Dan's function takes an array, gives back a single integer. Ivan's function takes that integer and turns it into some other number somehow. Seth's function takes that original array and the number that I output and outputs a second array of some other sets of values. Carlo's function takes an array and the output from Ivan's function and returns a set of doubles. And then Alex's function takes those two arrays that we constructed and returns, in this case, it's a double, right? Returns a single double. Each one of us has been working on our function independently, right? But when we put it all together, we find out that the final result is wrong. So the question is, where is the problem, right? We know this simple 5 lines of code is correct because that was, say, in the assignment we were given. So the problem is in one of the 5 of ours functions, but we don't know which one. So just like with testing a whole program, each part of that program, so each one of us should have tested what we wrote before we put it all together. So when I was writing my function, I would have made sure it works before I gave it to the other people in my group. And we can do that individually for different parts of our program, even if it's not to do it in a bigger problem. So we call each one of these portions of a program that we can sort of test a unit, right? So we can test each particular unit to make sure it's working before we get into something more complicated where it might be harder to find the error. So to do that in class, we're actually going to use a system called JUnit, right? So JUnit is built into Java. Some of you may have used this in CS1, and some people may not have. But this is our group project up here, right? And we're going to write some test cases. So maybe we call this group project tester. And what JUnit does is we can write these little validation scripts that say, well, what should happen is if I give final result this array A, it should return a number that's 3.2. And I'm going to say, I'm going to assert that this is equal. And when I run JUnit, it's going to run each one of these tests and tell me which ones don't pass. Meanwhile, for my own function, I would have written some other test cases that when we're given A, well, I should return 15. That should be the first step in that. And Seth's function, if you remember, right, Seth, he took an array and a number and output a second array. So he needs to use something not assert equals, because assert equals compares a scalar with another scalar. He wants to check a whole array, so he's going to use assert array equals. And what it's going to look like in Eclipse or in IntelliJ, when you run something as a JUnit test, it's going to provide you with a set of results as to which of these assertions passed and which ones didn't. And the thing is, each one of us has written our own set of test functions for each of our functions. And as we put them together, maybe we realized, I needed to adjust mine a little bit to fit in here. But it should still pass all of the tests that I needed to do, right? So we're never going to remove a test from our unit tests. We're only ever going to add to them. As we figure out that maybe in the bigger context of things, we were missing a corner case or missing an edge case that we needed to confirm that our program was solving correctly. Right? So in lab, we'll go into the actual logistics of using JUnit, but this is the idea behind using unit tests, right? Is that we want to be able to, say it's a function that just finds the max in an array. right? That's an easy thing to check. But once we get it into a larger thing that takes the mins of all the maxes, right, you want to know that your max function works correctly. So, yeah, like I said, the logistics of this we'll go over in lab. Normally you run this without a main. For those of you using Repellit, that's not quite true. And again, we'll go over those in detail.